In this video, we are going to continue our discussion of section 8.2 and 8.3, the series solutions about an ordinary point. We are going to work today on actually finding a solution for this. We can find a solution to this differential equation in the form of a power series. So we are going to start like we have in some other problems where we take an initial guess. If you have printed this off and you're using my notes, I have given you, I think, 2 to 3 pages. If you took those off, I would write small. This problem is going to be a doozy. So let's start and make our guess. And our guess is going to be a generic power series polynomial. So c to the n is just some constant, some coefficient. And we talked about this in the last video, what that means. If I'm going to plug a guess in, I got to have all the derivatives that are there. So I'm going to find my second derivative. To do that, I got to find the first one. We learned in that first video that we up our indice by 1, and then we take our derivative of our inside. So the n comes down times cn x to the n minus 1. We can then now take the derivative of that, and we have the summation of n equals the indice goes up again. And I take the derivative of the inside, so n times n minus 1 times cn x to the n minus 2. Same as our normal derivatives, the only thing is we're working inside of a summation. Right, just like our methods in the past for this semester, we are going to take each thing now and plug it in. So I have that first summation from n equals 2, it's the second derivative of infinity to infinity of n minus 1, n times n minus 1, c to the n, x n minus 2. And then it's going to be plus x times the summation of y. So it's n equals 0 times to infinity, c to the n times xn. And we know this dE is going to be equal to 0. All right, so we just plugged into the dE after we made our initial guess. I guess I should be writing this guess. So there's our guess, and then we're going to plug it into the dE. I'm going to simplify this a bit before I start working. So if you focused on that first set of problems for a little bit before starting this is where you're going to start seeing that come back in. Okay, the x just goes in and multiply, so I got n equals 0 to infinity of c to the n x to the n plus 1 equals 0. All right, that's just doing this x to the first times x to the n. Putting those together, remember I add my exponents. All right, I have that now. This becomes the problem that we started with for this section. I need to match my x's, so I'm going to do k equals n minus 2. This is if you write notes off to the side, this is sub-index. That's what I called it in the last video. So k equals n minus 2, so that means n is k plus 2. That's just adding 2 to the other side. I like to box this to make it break up my work. And then the second one is k equals n plus 1. If I solve for n, I get n equals k minus 1. So let me box that. All right, now I make my subs. So it's a summation. Okay, n equals 2, so that means k equals 0. That's plugging it in here. So k equals 0 to infinity of n. Oh, I got to sub that, k plus 2, times, okay, if I plug in k plus 2 for the second n, I get k plus 1, c to the k plus 2, and then x to the k. That was on purpose. Perfect. So that's that one. Now I use the second set of subs. I get k equals, n is 0, so that means k equals 1 to infinity, and then I sub my n's, c to the k minus 1, and then x to the k. Cool, we have that set. So now the next step was to let out terms. If we need to, we do. We have a k equals 0 and a k equals 1. I can match them if I let this come out, k equals 0. And then this one, there's nothing. So put an x in that box. All right, so that's that second line. Now I'm going to let out k equals 0 for the first one. So I get 2 c2 x to the 0, which is 1. That's the only one I needed to let out. The other one had nothing. So this becomes k equals 1 to infinity of k plus 2 times k plus 1 of c to the k plus 2. Nothing else changes. X to the k. Plus, I didn't change this one. I said the k's are great. K minus 1, x to the k equals 0. So we're almost to the end of the problems that I had you guys set up front. So now I have 2c2 plus I can do one summation, k equals 1 to infinity. I'm going to open my bracket. I get k plus 2 times k plus 1, ck plus 2, and then no x to the k. We're going to factor it out of both. We got ck minus 1, factor out x to the k. I got it right there. All right, so this is where we left off, except for that equals 0. I know that I have something, a constant, and that's this constant here, and then I have a second term here, and I know that when I plug everything in, I need everything to be 0. So that tells me that I have a system. I have that the first thing, 2c2 equals 0, and then this is the reason that we factor out this x to the k, because for that to be, and we have everything positive, our ck, our k plus 1s and everything like that, the only way that term is going to be 0, because x is just a variable, has nothing to do with it. The k's up top are not going to make it 0. It's just this term. That means that that term in itself has to be 0. So we get this whole thing here, and that's also equal to 0. We're going to solve this system, and it will solve our problem. I'll have to help you put it together, but we'll get there. All right, a couple things here that we can get right away. We know that C2 is equal to 0. So I'm going to box that. And then at this point, we are going to factor for solve for one of our C to the K plus 2 or K minus 1. What you're going to always want to do is you're going to want to solve for the bigger one. All right, so that means I'm going to solve for ck plus 2. That means I would subtract my ck minus 1, and then I would divide by the k plus 2, k plus 1. That's just solving that equation right above. And I always solve for the bigger k, the bigger indice. If you're unsure which one's bigger, plug in 0. 0 plus 2 is 2, 0 minus 1 is negative 1. 2 is bigger than negative 1. So this is, if I follow that indice, the indices, this is for k equals 1, 2, 3, and we get that from here. All right, so that's where that comes from. Now we are going to make this giant list. And you're going to see how this all comes together. It's hard for me to kind of explain to you why we're doing it until you see how it comes together. And then you're going to be like, oh, it's actually a pretty genius method. And it's a follow your nose method, meaning like somebody was like, I wonder if a series would work out, and they started working it out. So this is how the list starts. I have C2 equals 0, and then I have this other formula here. We're going to always be able to grab a handful of things from the system. We'll have stuff like this, initial conditions, or some small formula, and then we'll have a generating formula that's there at the bottom. We're going to start with k equals 1, and we plug that in. So we get C3 when I plug in k equals 1. This is the bottom formula there. Minus C, if I'm plugging in 1, I got C0. And then plugging in 1, I got 3 plus times 2. So I get, and you'll see why I want to write it like this. It'll help us. Negative 16C0. And I'm going to stop for a moment, and then I go to the next K. How I know how to stop on each line, because we're going to do some substitutions. We'll see. I'll just show you. So K equals 2. I'll plug that in. I get C4 equals, and it's going to be negative C. If I plug in 2, I get 1. And then if I plug in 2 for the bottom, I get 4 times 3, which is 12, which is negative 1/12 C1. Sorry, there's like a point in there, it looks like. There we go. And, okay, we keep going. K equals 3, I get C5. And then I got negative C2. And then plugging in 3 up there, I got 3 plus 2 is 5. Times 4 is 20. And this equals negative 120 C2. But remember, C2 is equal to 0. Right, way above up there. So this is equal to 0. Things are going to start repeating themselves. We're going to sub in, and we're going to be able to get everything in terms of C0, C0, right? C0 or C1, or it'll be 0, the whole thing. So keep going. You're going to keep going into this list until you have, my rule of thumb is I do, how many are we going to do in this one? I think I do at least 3 each. So I want, we want to stop, and I'm going to make a note here. Stop when we have 3 C0s and C1s. All right, that's when we're going to stop. Okay, so we're going to keep going on this list because we could go forever, really. With k equals 4, we could just keep going. 5, 6, 7, on and on. So this is C, k plus 2, so it's 5. I can't add. 6. C6 minus C3 over, and then I plug 4. 4 plus 2 is 6. 4 plus 1 is 5. So 6 times 5 gets me 30. This is negative 1 over 30, C3. So this is why I write it like this, negative 130. And then now I can replace C3. C3, if I look above there, was negative 1/6 C's not, right here. All right, that's C3. I plug that in. Now I multiply. I get 1 over 180 C naught. So there we go. I have a second C naught. And then I keep going. K equals 5. And I get C7 equals negative C4. This is plugging in the formula above at the top there. And then I plug in 7, and I get 42. This is negative 1 over 42, C to the 4th. Then I just plug in C to the 4th to simplify it down to C naught or C1. C to the 4th is negative 1 over 12 C1, which is 1 over 504 C1. And I keep going with my list. I get K equals 6. All right, so I got C8 equals negative C5, and then I'm using the formula above, but I don't want to keep scrolling back and forth, so I have my list here. This is going to be a 56. This is negative 1 over 56, C to the 5th. So I have C to the 5th, it was 0, so this is 0. You see there's a pattern, it'll be 0, something C's not, something C1. I keep saying C naught, I'm just going to tell you what that means. It's C0, sub-0. I don't know where that actually came from, but I've heard it my whole time in math and science. So if I say it, know that I mean C sub-0. So now I go K equals 7. That's going to give me C9. That's negative C6 over 72. That is negative 1 over 72 times C6. Negative 172. I look above to get C to the 6, or C sub 6. That is 1 over 180 C naught. And that is negative 1 over a big number, 12960 C0. K equals 8. Okay, so I'm almost done. I have 1, 2, 3 C naughts, and then I have 1, 2, and I need one more C1. So we're almost there. So this will probably give us our C1 if we look at the pattern. This is C10. That equals negative C7 over 90. That's negative 1 over 90 times C7 equals negative 190 over times, okay, C7 is 1 over 504 C1. And that is negative 1 over 45360 C1. Now I have 3 C0s and 3 sub 1s. All right, so now we are going to actually write our answer. I know that's a lot there, and this is where it comes all together. So our guess was y equals the summation n equals 0 to infinity of c sub n x sub n. What this means, this is, if I plug in 0, I got C0, x is 0 is 1, C1 x1 plus C2 x2 plus C3 x3 plus C4 x4 plus, and so on. We are going to sub in literally every one of those. So I would write pretty small here. Y equals, I get C0 plus C1x. I'm not changing anything, I'm just writing this. And then I got C2, and this is where we're going to start subbing in. So C2, if I look up, way up here, C2 was 0. So it's not there. So now, so that's gone. Now I do C3x3. Well, C3, if I scroll up, C3 was right here. It was negative 1/6 C0. So I got negative 1/6 C0, and that was x to the 3rd. Now I do plus, and then we're going to do C4. If I scroll up, C4 was negative 1/12 C1, and then I keep x to the 4th. So I've done those. I've written that down, I've written that down. And then C5, okay, if I look back up and I scroll, here is my C5. C5 is 0, so that's gone. So I go back down. Okay, I got C6. C6, if I go back up and look, I have it written here, is 180 C0 x to the 6th. Then I have C7, which is 1504 C1 x to the 7th. Okay, and then I believe 8 will be 0, so that was C8. If I look back up, C8 was 0. And then I got two more here. I got minus 1 over 12960 x to the 9th, because that was C9. And then the last one that we're going to write down, 1 over 45360 x to the 10th. I forgot my C. C on the last one too, didn't I? So don't forget that. This is going to be, let me scoot over a little more. That was C0. And then this was C1, x to the 10th. And this goes on forever. We could have kept going down our list to get more of those answers. Now, what I want you to notice is every term either has a C0 or C1. What we're going to do is we're going to write down two solutions. Y1 is going to be all the terms with C naught. So I'm going to write down those C naught terms, but I'm going to factor out what they are with the C naught. So the first C naught, that would give me a 1. And then the second C naught, it gives me a 1/6 x to the 3rd. And then I'm going to underline these because I'm going to get lost. There's that one. C naught here is 180 x to the 6th. C naught here is minus 1 over 2960 x to the 9th minus this one sorry, my handwriting is getting horrible. All right, there we go. 1 over 45360. Oh, that was a C to the 1st. So that's all we have for that one, actually. So we can do plus, and this goes on forever. So there is my first solution, Y1. It is that infinite series that looks like that. There is a formula you can get to this. The book I use to get my notes from, it's tough. It's very tough, and if you don't have your summation formulas memorized, which I don't, so I'm guessing a whole lot of you do not, and if you do, that's great for you. Proud of you. But most of us do not, and so I don't really practice going to the formula. We just leave it here. That's one answer. The second answer are all my C1 answers. So I just factor those out. I got x minus 1 over 12 x to the 4th plus 1 over 504 x to the 7th. And then the last one, 1 over 45360 x to the 10th. That is and then that goes on forever. These are my two solutions for that DE, that is an infinite series. And then we also can come up with, a general solution that is y equals C1 times Y1 plus C2 times Y2, like we have in the past. Now we just have an answer that is an infinite series. Recommendations for this: give yourself grace. Go very, very slow because it is easy. They're easy to mess up, meaning most of the steps aren't difficult. I think the only calculus involved is the derivative in our guess at the very beginning. That's it. The rest of it is just algebra, but the problem is the problem's super long. You have your notes in front of you, or you just watch this. It takes quite a bit, which means there's a lot of room, several steps that you could make a mistake in. So go slow. Do this. If it were me trying to get these type of problems down, don't go to homework and get it down. What I would do if it were me is I would do this problem again, and then I'm going to do a second example. I'm only going to do two because they're long. Two examples, and I would work this one and try to match the answer at the end. You have the solution, you know it's correct, given my arithmetic is correct, but I've worked it several times, and I checked my solution. Work this one until you get the method down. That's all you're trying to, the numbers aren't important when you're doing up front, it's just the method. So use this problem and the next example to be your run-of-the-mill, or not run-of-the-mill, that doesn't make sense, but the repetitive problem that you do to get the method down. and then use homework as your practice. So once you get the method down with these 2 examples, then try the homework problem. Then you're not going to be wearing out the homework problem. So the problem with this type of this kind of stuff is in the homework, I'm not going to give you a bunch of problems because they take forever. And then also, these are kind of hard to find that are tame online. So work the examples, use those to learn the method. I just given you the how to do it and a solution to go by. And then once you get the method down, switch to homework. Use those to practice. All right. And then when I give you the review, use the review to quiz. Cool. So this will be the end of this one. I'm going to do another example in the next video.